Hi. Yeah. Hi, everybody. So we're going to talk to you today about all the new great HTML5 support that we have in the browser. Eli Fidler is the chief architect for our WebKit engine and the whole kind of hardcore stack. And we're going to take you through, literally one by one, all the different pieces of HTML5 and what we support. Oh.
All right. So the WebKit browser, the web rendering engine that powers everything web on the device, we brought to the BlackBerry platform in BlackBerry 6, and we've been evolving it, BlackBerry 7 and the playbook, and now BlackBerry 10, with pretty significant jumps every time that we've done it. So BlackBerry 6 shipped in 2010, summer sometime. And since then, we've certainly come a long way. So since then, we've actually become a leading implementation of HTML5. You saw our HTML5 test score in the keynote yesterday, and it is quite a big number. Certainly competitive with every other mobile platform out there and most desktops. So in this session, what we're going to do is talk about what we've done since BlackBerry 7. So some of the new features that we've introduced and what they would allow you as a web developer to do with your content. Sorry.
So first, let's start about kind of the miscellaneous stuff. These are not specifically, HTML5 APIs. These are more like best practices. How do you deal with things? So, one of the big things is browser detection. We're web guys, so we generally don't write content that's targeting a specific target that hard codes that knowledge in. We try to build cross-platform content. So at some layer, browser detection becomes important. We have a new user agent string that came into BlackBerry 10. What we've done was to actually take the word BlackBerry from the user agent string. The reason we did this is because there were a lot of websites out there and web content that explicitly targeted BlackBerry with the lowest common denominator content that they could muster. Basically, they were targeting BlackBerry 5 and BlackBerry 4 and kind of never moved forward to exploit the great browser that we have. And we found that by just removing BlackBerry, most sites were going to send us now like premium mobile content, which our browser can handle without a hitch. So this was very critical for us to kind of design that new user agent string, and basically that's what we get here. Right? Now, this is a little bit controversial. Really, not traditional, but like top designers, web developers will tell you that sniffing the user agent string is evil. You really want to work with browsers at the level of features and use techniques like feature detection, responsive design. And one of the leading libraries out there is Modernizer, which is a great library that allows you to test at the feature level, can this browser support accelerated 3D CSS transitions, and start using that. So you can build an application that's a lot more dynamic, a lot more tailored to the browser that you happen to run in. And you can have web content that works well on BlackBerry 7, on Playbook, and on BlackBerry 10. Right? But for those of you guys who may not necessarily build web apps and own web content, a lot of kind of web content infrastructure still have user agent-based kind of routing to particular versions of web page or content, right? And so that's our user agent string. Another thing that's a little bit different from before, at least on the playbook, is that Flash is now off by default in the browser. So users can still go into the settings screen and set it back on, but by default, it's off. So if you have content and you want to take advantage of Flash, you may have to think about notifying your users in an interesting way and have them kind of make that switch. We'll have a Q&A session at the end.
The device, like touch, it says touch here. Does it refer to more than one device or the touch device? I have an example of the user's agent here.
Yeah. So we can address that in a Q&A and go in more details. Okay.
Okay, so these are the window dimensions of the first BlackBerry 10 launch device, so the equivalent of the Dev Alpha A's and Dev Alpha B's that you have. The native resolution of the device is 1280 by 768 in portrait, or sorry, in landscape. In CSS pixels, those are the numbers. So in the browser, a website sees 480 by 342 CSS pixels. We do DPI scaling to make content that's designed for other mobile platforms work equivalently. So in particular, we DPI scale to 160 DPI. This is the same thing that most of the other platforms do. If you're running full-page web content, so that is in a WebWorks container, or if you've launched the browser Chromeless from a home screen bookmark, then you get 570 vertical CSS pixels. The browser Chrome itself is 28 pixels at the top and 62 pixels at the bottom. So hopefully you were all at the keynote. You all saw what the new browser Chrome looks like, but we will be showing some demos, so you'll have a chance to see that as well. If you're trying to target your web content to what's available on a BlackBerry 10, those are the numbers.
So this brings an interesting topic, which is viewport management, right? Which is a favorite topic of people who are advocating for responsive design. Some people have been abusing things that are never been spec'd, such as the device DPI within the meta tag. And this is something that WebKit at large has been removing. So it brings up interesting stuff and interesting kind of best practices, right? So the effective pixel ratio that you have out of the box is 160 DPI. This is important for the quality of graphics you want to put in, the font size you want to use, and things like that. If you do not use the viewport meta tag at all, right, we're basically one-to-one with the native resolution. So you do get 1280 by 768. If you use the viewport meta tag, then we basically do scaling to the dimensions, the pixel, CSS pixel sizes that we saw in the previous slide. What we, however, do is we always zoom to fit. So we have special algorithms to try to show the web page in the best way possible. So what that has for effect is that the zoom level essentially affects how many pixels you're actually seeing and changing the effective DPI for the end users. So there are JavaScript APIs to deal with this, and there are lots of responsive design techniques. That's what it's called. If you go on the web and search for it, you'll have tons and tons of material of the best practices and how to deal with those types of things. But the key lesson here is hard-coding content for a very specific DPI and a very specific window size is going to hurt you in the long run. You don't want to do that. The web is fluid. The web is dynamic. You want to make sure that your code can adapt. And especially when you look at BlackBerry 7 dimensions, you look at Playbook, and you look at BB10, there are techniques to really make content fit and work within all those dimensions. Right? That's where the web is actually pretty strong. You have the tools to do that. So the technique, basically, if you do want to manipulate things a little bit, right, one thing, for example, is the only way to specify the zoom level or lock it so users can't do pinch zoom is in the viewport meta tag. But if you do that, then you start having viewport management from the browser. So how do you reset it back to one-to-one if you want to do kind of a high-density kind of environment? And basically, you have to use a little bit of JavaScript here, do some calculation based on the window device pixel ratio, and basically regenerate the meta tag through JavaScript. Right? It's a little bit hacky, but that's what people do.
OK, so that's all we're going to say about viewports. Let's show some cool demos. The first thing we're going to talk about is CSS filters. So this is a new feature where a long-standing browser feature, SVG filters, that very few people have actually used, is now brought to DOM. What this means is you can do image processing on DOM content. So you put some divs in your page or images or whatever you like, and then you can specify declaratively in your CSS that you're going to run some sort of image processing filter on it. And there's a number of canned filters that are available for you, and they have parameters. You can animate those parameters using CSS transitions and do lots of cool stuff. So I'm going to show you this demo. This is a desktop demo, unfortunately, so it's a little bit not sized for the screen that we've got it on, but it looks cool anyway. So can I get the HDMI? OK, so this is the new browser. And I'm just going to go to this site here. Live demo. Hopefully it works. Oh. OK, so this it fetches an image there, I believe randomly from Flickr. So I'm going to pick a different one because I don't like that image. And then they send me a broken image. Whatever. Give me the same one. All right, so this page basically has, you can see -webkit-filter. This is a way of specifying the CSS property that you're going to animate or that you're going to change. And here's the image up here. So you can see there's a number of sliders here. And if I move one, it's black and white. That's not going to do anything. So here, I'm inverting black and white. You can see as I move the slider that it's actually processing the image. So all of this is doing is changing the CSS. And you can see, hopefully it will show up on the screen, that at the bottom here there are some buttons that actually do animations. So all it does is set up a JavaScript timer. And here, there's a timer. I don't know if you can see it. But what's happening is the image at the top is getting more blurry and less blurry by just animating one property that's sent into the CSS filter. If I manage to get a non-grayscale image, I could show you the grayscale one.
So grayscale, blurring, hue, so you can make like a sepia kind of tone, a lot of capabilities. Yeah.
So there is a blue one. And now I'm doing an animation where it's desaturating progressively. And this is all done using hardware acceleration. So you can do this without affecting like scrolling of the page or anything like that. It happens at 60 frames per second, and as long as we can process the image fast enough. So anything that's a reasonable web size image, we can do pretty efficiently. Yes, so CSS filters is in the standard.
Yeah. All we're talking about today are standard-based, right? When it's not standard, we have a section about some of the stuff we do specifically. We'll make that explicit in the presentation. Correct, correct. Yeah, yeah. I mean, a lot of CSS stuff still have prefix.
OK, can we go back to the slides?
So the key things here that we've done, right, is you've seen in the keynote, we achieve a really high score at HTML5 test. And guys, this is not the ultimate measure of goodness, right? HTML5 test is a very thorough inventory of HTML5 features, and we like it just as a basic way for us to compare our feature with other vendors. But it's also interesting to see within really a year plus, from OS 7 to Playbook 2 and now BB10, the amount of progress we've done, right? So those numbers basically denote real progress, real additional APIs and HTML5 support that we've built into the browser. And it's fairly significant.
So, I mean, we're going to just walk our way through the HTML5 test scores. Some of this stuff is kind of table stakes these days and hasn't changed that much, so we'll go over it a little bit quickly. So this is all the HTML5 parsing. We now have a standard HTML5 compliant tokenizer and parser. That means that you can do things like have SVG and MathML embedded in your text HTML page. It supports the HTML5 doc type. All of this stuff has been working. Canvas. So we have had 2D Canvas support since BlackBerry 7, well, since BlackBerry 6, actually, but BlackBerry 7 was when it was really starting to get solid. And here, the API support is the same, but we've seen massive performance improvements. So you can definitely see that Canvas games that in BlackBerry OS 7 ran, sometimes, it depends on the game, but let's say it was something that ran at, let's say, 15 frames per second. We're easily getting 60 frames per second on BlackBerry 10 now.
The video tag, basically, is a similar thing. We've had video support fairly early on, but it's the little details. So subtitle support came in, right, in BlackBerry 10. And we basically added more codec support like MPEG-4 and H.264, right, since RimOS 2.0, the tablet OS 2.0. So the video functions, it is hardware accelerated, and really it's the subtitle support and the additional stuff. What we still don't have is additional codecs. As you guys probably know, there's a lot of conversations about codecs, legal issues, and so on. So there's no plan today to support those guys. It may change in the future, but right now, video support is for us fairly complete.
Audio is a similar kind of story. We introduced AAC and PCM support in the playbook, and we've now introduced Ogg-Vorbis support in BlackBerry 10. But mostly it's been codec improvements. We've also made some functionality improvements here. So we didn't have good support for multiple simultaneous audio tags before BlackBerry 10. Now that works pretty seamlessly. And it's now actually usable for gaming and that kind of thing, as long as you don't need super low latency or that kind of thing, where you need to go to something like web audio.
So elements, this is like a big section where we look at all the different HTML5 elements. So section elements, full support. We've been very HTML5 compliant for quite some time now. And these are all the things, right? Section, nav, article. These are all the new HTML5 goodies, which I see used very little. And these are really interesting elements that have very good semantics in HTML5. So rather than have generic divs, I really I recommend that you guys look at those elements and start using them more actively. They're really good stuff. Oh,
You keep doing elements.
okay, I keep doing elements? Okay, fine. So, I mean, next one is just grouping stuff. So, you have an image with a caption, or you have a label for a form, things like that. Again, we actually did not have good support in BlackBerry 7 for that. We've been ramping up where now we have full support in BlackBerry 10. So this is very good for very responsive kind of design type of techniques where you want labels that are associated to elements and have the browser figure out how it all gets grouped. There's also text level semantic element. I actually don't quite know. I've never used any of those guys.
So particular Ruby support works now. For those of you not familiar with Ruby, this is mostly used in East Asian languages where they do annotations on text. And we did support the elements before. Now rendering is significantly improved. So if you're making Japanese websites, for instance, then this would be important to you.
Okay.
So Ruby elements are like small text that's annotated after big text that gives you more context about the meaning of the text. And rendering of Ruby text in particular before was basically just scaled down versions of the larger text, which is not really that usable. So there's some special Ruby handling now that makes this work much better. But it's basically unused outside of the East Asian market. So if you're targeting your content there already, then you probably already know about this and you're happy that Ruby works better now. If you don't, then you probably don't care.
The next kind of section of elements is what I call interactive elements. So menu is a big one. Menu is still kind of fluctuating, but this is something that we have partial support, and that hasn't really changed throughout. The big change is just the details element that came in the RIM tablet 2. So this is an area that we continue to kind of enhance and work on. And for the global attributes or method, this is basically how you can insert markup and stuff. This is, again, stable stakes, change attributes and store things in DOM elements. This has just been done since the dawn of time. We had this in BlackBerry 6 already.
So forms is definitely an area where we've improved, and we've improved not so much on the standard or the API support in BlackBerry 10, but definitely the usability of all of these things is something that we've worked on in the new BlackBerry 10 browser. So you've probably seen this. It's one of the big touted features of HTML5, and this is letting the content developers specify the type of input that's going into a form and the device or the browser reacting appropriately. So providing, for instance, appropriate virtual keyboards or appropriate input controls for date or for URL keyboards or telephone keyboards or that kind of thing. So we started supporting most of these elements in BlackBerry Tablet OS 2.0, and then in BlackBerry 10, we have some really nice pickers for dates and that kind of thing that are very touch-friendly and easy to use for the user.
Oh, the blue box is just the delta. So the blue box just says this is the new thing since the previous version. Oh, okay. Just to make it visually easier. Exactly. From 7 to 2 and from 2 to 10, right? So if there's a blue box on 10, it's new in 10, a blue box, right? That's.
Yes.
Yes, yes.
So these are all localized in the user's chosen language for the whole device. So if they set their device language to Spanish, then the time picker will be in Spanish.
So
and localized into the region that they've selected as well.
Yeah, so I apologize, like we are recording the session, so it's better to just write down your questions and then you can ask the questions in the microphone so they actually can be part of the session.
Okay, so do you want to ask that now or do you want to hold it? Okay.
Let's hold it.
So here's some more form input elements. You can see that we have type equals range, we have type equals color. This is still partial because the spec has a couple of attributes there that aren't widely supported at all. So that spec, I think, is still iterating. But we do have a color picker now. That's pretty nice. And we support the other types as well.
One thing I see you guys like taking pictures and stuff. We have the URL here in the bottom. So that is really just screen captures of HTML5 tests. And we've already created a screen that has the comparison of the 3 browsers. So you can go, and for in-type tyrant, you can see more details further down at the attribute level and all those things. So let me see. OK.
You can also download the slides after the presentation.
Sure.
So feel free to take pictures if you like. And then you see some other things that are not input, but other form type elements that now have much improved support in BlackBerry 10. There's a couple of more interesting ones. So we've started introducing form validation that works nicely on touch. So this is like things like the pattern attribute and required. While it was supported before, you got the JavaScript events back. Now we have some UI around it that works significantly nicer than it did before. And then some interaction with the virtual keyboard as well, things like autofocus and autocomplete support. This now started to work much better in Tablet OS 2.0 and now works, again, even better in BlackBerry 10. You have some nice control over how the virtual keyboard will react to the form input that you have. We have some improvements in CSS selectors. These are basically giving you some new functionality that was introduced pretty late in the CSS3 process for the CSS selectors. And the last part of forms, we have not really changed anything in the events. They do the standard things that they've always done, but form validation is really starting to work much better.
So drag and drop is a kind of controversial one, right? So drag and drop is not drag and dropping within your application. It's drag and dropping typically from the desktop into an application. So from a mobile perspective, it really doesn't make any sense, right? Because you generally have an application that has the full screen. So there's no support there, but on mobile, we argue that, and no other platform does it. It's just not possible. I would argue it just doesn't make sense.
HTML5 editing is something that we've supported pretty well all along, although again, we've made some improvements on the UI side in BlackBerry 10. So content editable, this is basically an attribute that you put on any HTML5 DOM element. And then if you set keyboard focus on that by, say, putting the cursor there, you get a virtual keyboard. You can type into the DOM element. So this is used pretty widely for things like blog posts or email composition. And the experience is definitely much nicer on BlackBerry 10, so it integrates nicely with text selection, cut and paste, and context menus, and that kind of thing. But the API support has been there all along.
Spell check, same thing. Got it into the tablet OS, but a lot of good usability type of improvements in BlackBerry 10. So the core support is there, and it's nice and usable.
And just some miscellaneous things. So one thing that we've turned on is microdata. If you're familiar with microdata, this is a way of marking parts of your page as semantically containing things that are not obvious from the markup. This is very useful for search engine optimization and for the browser being able to figure out some of the context of data in your page. So we now have support for the microdata APIs. And we've also added support for custom scheme handlers. So this is basically custom protocols that you can access through XML HTTP request or that sort of thing. And you can set a website as a handler or web URL as a handler for that custom protocol. So this is something that was kind of introduced in desktop Chrome a little while ago and is now getting some more widespread support. So we added that in BlackBerry 10. We don't currently have custom content handlers because we think that there are some fairly serious issues with that spec, but something we're definitely monitoring for the future.
One miscellaneous stuff is just security. So there's a lot of work happening around building more complex web applications, and security is a big thing about it, right? And people want more controls around iframes, for example. So we basically, seamless iframe is basically the idea that the iframe is just flows and inherits some of the CSS stuff. So it's a way to combine different sources of content in a thing that still is isolated, but shares some of the common CSS and look and feel. So this is really good for integrating different sources of content and styling it in a single consistent way. In-frame with inline contents, I'm not sure what that is.
This is where you have an iframe where you're explicitly specifying the contents as opposed to having the iframe load a URL.
Oh, okay.
And this is something that was new in BlackBerry 10 as well.
Okay.
Also, you could have the HTML5 right inside, inline.
Yes.
In the
Yeah. So that gets you the properties of an iframe where it is a separate document, but the content could actually be in the same .html file. So you don't have to make a network request for it.
It's like a splash page.
Yeah. Yeah. And the next one is scope style elements. So this is something that's getting also a lot of good press around CSS. And you want to be able to add a style or a CSS but within one portion of the document and not have it bleed to the entire document, right? Today, a CSS is kind of global. So this is something that's happening, but there are lots of issues still with it from a standard perspective. So we support the basic functionality, but we do expect those things to evolve, maybe significantly. We don't quite know, right, over the future. But it can be very useful, again, when you do this integration of multiple content together. For content management system was the main driver for these types of requirements. Location and orientation, piece of cake, right? We've had this, working well, and basically it's just been improvements around performance for getting geodata and device orientation. So device orientation was already in the playbook and used a lot for games, for example, or augmented reality type of applications.
So WebGL, this is everybody's favorite cool new feature. We introduced it in the Playbook OS in 2.0. It wasn't in the 1.0 OS. And if you've used WebGL on a Playbook, you know that it pops up this very nasty sounding dialogue saying WebGL is going to steal all your data. So there were some definite security issues with WebGL previously that we've sorted out for BlackBerry 10. We've also made it much more robust. So there were previously some denial of service issues with having expensive shaders in your WebGL. For those of you not familiar with WebGL, it's basically a fairly low-level API that gets you access to the underlying OpenGL hardware and then putting that inside a block-level element inside your web page. So you basically get OpenGL in a web page. The question was about WebGL, whether it has experimental. It is still accessible through experimental, but it works. And coming with WebGL, although not necessarily tied to WebGL, is some of the interesting data types for passing binary data back and forth through different web APIs. So the main API is array buffer. This is a way of basically saying, rather than stringifying everything, which was the standard way of, say, doing a post message with a web API, you can now actually send a binary array buffer without having to stringify it.
And this is something important because it came through the WebGL spec, but it's used everywhere. So in sockets, XHR2, right? Get user media to basically get access to binary data, the notion of a blob. So this is something that's getting a lot more wider kind of use, right, across all HTML5 type of specs. Communications, right? So XHR2, right, is the big thing. bringing up things like, download status. So you can do a progress bar, for example, when things are happening. There's more flexibility, more support for uploading files and so on. So we've really, fairly completed the support there. WebSocket also, it's been a little bit rocky. The spec has changed back and forth, so there were breakages right around, the playbook time frame. But now it's starting to stabilize around the standard, and we have a good implementation in place. So for your modern web applications to talk to different endpoints, server-based, we're really covered.
So in particular with WebSockets, if you are building something with WebSockets, then you know about all these protocol changes. We have followed the rest of the industry in deprecating HXE76, which is the original protocol for WebSockets because of some security issues. So if you do have WebSockets-based applications and you require the old version of the protocol, that will now start to break everywhere, including on BlackBerry 10. The question was whether we have a push service for WebSockets. We don't have a push service for WebSockets specifically, but certainly our BlackBerry push service is available as a WebWorks API. So if you want to use the BlackBerry infrastructure to do push, then that's something we make available in WebWorks. Well, WebSockets isn't really about push. WebSockets is about connections and binary data transfer. So push is about notification, really, and that's kind of an orthogonal issue.
So Files API, again, kind of running up the support on BlackBerry 10. File reader, so you can actually get access to the data in the file from the file system, get the text and the binary data, so support for both binary and text. And also, obviously, the file system API. So you now have a sandboxed environment that's accessible from the browser where you can get folders and files and navigate the whole thing. So these are nothing special. These are file APIs that you've seen in every operating system since the dawn of time. And now it's all fully supported. And storage is one area that's also very interesting. The big news here is IndexedDB. The web has been, W3C has been working with structured storage. And WebSQL was kind of the thing at the beginning, but it faltered. There's this requirement in the W3C that you need to have like 2 independent implementations of any spec for it to stick. And WebSQL basically never managed to get beyond 1. So people have started to move around IndexedDB, and this is doing a little bit better, and people are also liking just the more flexibility and better performance of IndexedDB at large. So we have support of IndexedDB today. What's our quota? What's the default quota we have? People always ask that.
So I mean, we're basically doing what most of the other platforms are doing right now, and that's to make 25 megs the default quota for most of these storage APIs.
And if you extend that, you generally get a prompt to the user to basically allow you to do that.
IndexedDB in Chrome, it is basically implementing old specification, and the specification has changed and it has a new specification. You are implementing the older version like Chrome or the newer version?
Well, Chrome has moved pretty far back. Like they're following the standards pretty aggressively. So the old IndexedDB standard is really old now.
So now you are following the new one?
Yes.
Okay.
So I'm going to show a file system API demo because file system API is cool. Again, a desktop demo, but hopefully this will actually work. Can we switch to the HDMI? All right, so this demo is a terminal application using HTML5 file system API. I'll zoom in there a little bit so you can see. Basically what you get is, it's that keyboard focus there, and I'm just going to make a directory. And maybe we'll make another one. And then we'll go into that directory. You can see now I'm in /B. So this is inside a sandboxed file system. There was nothing in the file system to begin with, and now I'm just creating stuff. Maybe I'll make another directory. And then one cool thing about this demo that I really like is they have this 3D visualization of what your current file system looks like. So hopefully I can actually get this to zoom properly. So there you go. And that's the total contents of my file system right now. Unfortunately, it's pretty desktop focused, so it's built using mouse events, which makes it somewhat difficult to interact with. But you can see I can create files here. This actually also is built to use drag and drop so that you can drop files from your desktop into it, which we don't have. But you can create a file system and write files to it and use it as local storage. And we use the standard APIs to do that. Okay. Can we switch back to the slides?
Yeah. And one question people always ask is the 25 megs is per store, so it's 25 megs for files, 25 megs for IndexedDB. It's the whole thing. So you're sharing storage across all those different access methods, file system, IndexedDB, and also session and local storage.
Right. Per site.
Per site, yes.
Okay, here's some more stuff. So web workers is something we've supported for a while. Typed arrays works nicely with WebWorks to get data in and out. This is a really cool one, local multimedia. So it says access the webcam. What this really means is get user media. You've probably heard of get user media. This is a way of getting webcam data into JavaScript so that you can do something with it. It's a part of the WebRTC spec, but it's kind of the first part that's coming to lots of platforms. And we do now support get user media in BlackBerry 10. Unfortunately, our get user media demo on stage at the keynote didn't work, but let me assure you it does work, and hopefully we'll get it working today. Another thing is web notifications. This is something we introduced in Playbook 2.0, and this is somewhat closer to the push API that you mentioned before. So this is a way for a website to send you a message, a notification, and we've hooked up web notifications so that that notification will go to the BlackBerry Hub so that it looks like any other notification on the device using the standard HTML5 APIs. Another new feature we've introduced is page visibility. So this is a way for your content to detect whether it's visible to the user, or for instance, you've put it into a background tab, like the user switch tabs away from your content. You know, get a JavaScript call that tells you that that's happened.
Well, one thing about the web notifications, right? It's not really push in the sense that it's not the infrastructure back. The JavaScript in the web page basically makes a notification that gets into the system infrastructure. So on a desktop, it might be like a pop-up tray or a toaster type of interface. On our end, it's going to be the hub. On Playbook, it was basically talking to the little pop-up that you had on the top left corner of the screen, right? So let's be careful when you use the word push, right? This is not push the way BlackBerry means push with real-time server-side events to devices.
Right. This is when the website is loaded, it can integrate with the notification system of the device. Right. We're going to do one more demo. Hopefully it works this time. This is the one we tried to do in the keynote. So can we go back to HTML? Let's just try this here. Okay, so with this site, you can see at the top it says people.opera.com wants to access your camera. This is a notification the browser's giving you. It's saying we're trying to use the Get User Media API. If I press allow, then you get a dialog. This is, again, the browser asking me which camera I want to use. So let's use the rear. There's all of you. Hi, everybody. So this is actually inside a video tag in the web page. We have a video tag that's pointing at an object URL that was created by the Get User Media API. And even cooler than just displaying it in a video tag is then we can do post-processing on it, and we can do things like this.
And that's WebGL, right?
Yes. So you can see performance here is pretty good. You can still render all the video frames. I mean, even when I have it all exploded out, I can still move it around, and the camera updates in all the pieces. So performance of this API is actually working quite well on BlackBerry 10.
You don't have to use Flash anymore.
And Flash is off by default, so this is not Flash at all. All HTML5 standards.
Audio is the last bastion of Flash, right? So web audio is going to solve this in the coming year.
Okay, can we go back to the slides?
There are a couple. 3JS is one of the dominant one. There's another emerging one that I've seen talked a lot recently. It's tQuery, which is basically a WebGL library that uses like a jQuery-like syntax to make it really simple, chainable, and things like that. These are kind of two of the leading ones. So more miscellaneous. Web audio, still no support. Lots of issues there. This is really, really, really cutting edge, but something that we intend to support as the device matures. And in terms of video and animation, we've seen here some examples, right? We have really good support, hardware accelerated. You can do a lot of things. So this example was into WebGL. A lot of people use and do processing at the canvas level. There are lots of libraries popping up that do image processing at the canvas level because you can get the actual bits, the actual pixels and the colors and all that type of stuff. So a very rich area of JavaScript, HTML, popping up around video processing.
These two APIs, full screen support, so this is brand new in BlackBerry 10. This is the ability for you to take a DOM element and make it go full screen chromeless. So this is typically used for video. There's a JavaScript API to trigger the video tag. We do pop up a dialog asking the user if they want it, because otherwise we expose ourselves to some pretty nasty phishing attacks, but it is supported now, and primarily we use it for video. And the other one, this is a really big one, is Request Animation Frame. Request Animation Frame is an API that is API compatible with set timeout, but basically is a way of doing JavaScript animations synchronized to the vsync of the device. And we now have good support for this in BlackBerry 10. It does lots of good tricks to make sure that you're using the most efficient, or using the CPU most efficiently. And we recommend that everybody use Request Animation Frame.
I tried Request Animation Frame and got 28 frames per second as an average.
So Request Animation Frame isn't magic, right? If you have a callback that runs off Request Animation Frame, and then your callback takes 100 milliseconds to run, we can't magically make that 60 FPS.
No,
but if your callback is fast, and it gets you under the frame time, which is 16.6 milliseconds at 60 frames per second, then you will get another callback at 16.6 milliseconds minus the amount of time that you took so that you hit the next frame barrier.
So maximum what you will support 60 or like more than like?
The device refresh rate is 60 frames per second. So the whole point of Request Animation Frame is that if you are to render something that takes 0 time, it renders at 60 FPS instead of 5,000 FPS wasting CPU.
Desktop Chrome sometimes gives 80 frames per second.
So that's the thing. There's a bravura thing, but it's stupid. If your screen is 60 hertz, right, which most laptops are, doing 80 frames per second, you will not see a magic extra 20 frames.
It
right?
creates problems.
Well, on Chrome, right, and people have been trying to place it, oh, we can do 100 frames per second, right? Your monitor is at 60 frames a second. So all the other stuff is wasted. So here the key point, right, what Eli said is that it is synced to the vsync of the display. Our display runs at 60 hertz.
Set timeout is incredibly inaccurate. If you picked set timeout 16 milliseconds, you would jitter 0.6 milliseconds per frame, and then you would drop a frame. So Request Animation Frame is clearly the right API for doing JavaScript animations. And JavaScript animations includes WebGL, right? WebGL is a JavaScript API.
Yeah.
So if you want to do WebGL animations, which is pretty common if you're using WebGL, then Request Animation Frame is a pretty critical piece.
I mean, I've been working a lot with game makers, right? Once Request Animation Frame is available, they never use anything else, right? I mean, it is what they need. But again, no magic. So you have to do a loop that takes less than 16 milliseconds if you want 60 frames per second.
Okay, so we're going to touch a couple of the non-standard things that we had to do. I know we're running out of time, if not out of time. So we'll do this a little bit fast. So WebKit overflow scrolling touch. This is something that was introduced in iOS 5 that makes subframes, like overflow scroll divs, scroll using the native scrolling physics. So we've also keyed off this value. We always allowed you to get the native scrolling, but we've keyed off this value to give you composited scrolling, which means we do it hardware accelerated, and that gets you much better frame rates. We've also introduced a small extension to that, WebKit overflow scrolling BlackBerry touch, which gives you the bounce. So our default behavior in Cascades is that if you have scrollable content and the scrollable content fits in the container on the screen, it doesn't scroll, but it still allows you to bounce. So that's what this does. There's no other web standard way of expressing that. Another thing that we've introduced is text overflow BlackBerry fade. Text overflow is the behavior of what happens when you have text that goes outside the container that it's in. And the default web standards here are either none, which means that the text is just clipped to the container, or ellipsis, which puts the ellipsis character at the right side of the container if you're in a left to right language. So we've added this BlackBerry fade to get the BlackBerry 10 user experience of having an opacity gradient fade. We could have done this with a WebKit gradient mask, but this is much more efficient. Gradient masks are one of the most expensive things that we can render, so we wanted to make a native API that makes this efficient. And this is widely used in the browser application.
Other things is around the input text. So again, with requirements from the BlackBerry 10 user experience, right? We had to do a few things. So for example, what does the enter key really look like, right? You can control what's the label for the enter key. So we have a bunch of values here, default, connect. So default, I think, is the icon with the, the angle with the arrow. But you can also say connect, done, go, join, next, and so on. These are labels. These are explicit iterated. It's fully national language enabled, right? These are not strings that you can just plug into the keyboard, right? So these are enumerated values. The other thing also is, if you kind of highlight a piece of text and you click on it again, it basically removes the highlight. The BlackBerry Video Keyboard, you may have cases, it's interesting, with the input type equals text in HTML5, you can say, I want a URL field, and the URL keyboard will come up, but you will also have the default browser error handling and a whole bunch of other things that come out of the HTML5 spec. What if you want to completely override that behavior yourself and do the validation yourself and do additional things yourself? So this allows us to control what keyboard actually shows up, but gives us more control in JavaScript and HTML about handling the actual input and management of that field entry. And then finally is basically the hide cancel. This is the keyboard, right?
So we've set up all of our default form controls to have a cancel button inside them, so a little X on the right if you're in a left or right language. And that is a way of just clearing the field, because this is very useful on touch devices where you don't want to type too much. So if you don't want that, then we've given you this attribute to turn it off.
It's common when it's search box. It's an easy way to clear the input. So we've added that for any type of input field. That's what it is.
And then this is something we've had for a little while. We still have it. And this is a meta tag called touch event mode that allows you to control how touch events get converted into mouse events. Most web content out there, especially desktop web content, is designed for mouse events. This is fundamental to the specs. And pages that are designed using JavaScript touch events have to deal with the fact that the browser internally has to convert touch to mouse events in order to support legacy web content. So if you specify nothing, we do our default, which is to try to be smart enough that if the user has designed their page for touch, it does touch. In particular, if they prevent default on the touch events, we don't generate the mouse events. And if they have designed their page for mouse or not explicitly designed for touch, then it does the right thing. But that involves, there's some delays in there to make sure that like a touch is not a double touch, double tap, and that sort of thing. If you want to turn all that off because you're designing your page explicitly for touch, then this eliminates all of the complexity in event processing and makes some things faster. So there's two modes that are not default. One of them is native. Native means there are no mouse events. So unless you have a Bluetooth mouse connected to the device, you cannot get a mouse event. And that requires you to basically design your entire page using touch. But you can see that the flow, from the user touching the screen to getting into the engine, is the simplest possible thing. And then the other mode is touch event mode pure with mouse conversion. What pure with mouse conversion does is it still generates mouse events, but it disables all the browser defaults. So the browser defaults, if we don't have either of these meta tags, is send the event to the page. If the page prevents default on the touch event, then we're done. Otherwise, convert it to a mouse event. If the page prevents default on the mouse event, then we're done. Otherwise, do the browser default. So you'll see things like touch scrolling, for instance. If you touch on something that has a touch handler, but the touch handler doesn't prevent default, then we have to wait for the page to tell us whether it captured the touch. And if it didn't, then we go back and turn that into a mouse event. And then if the page doesn't handle that, then we can start scrolling while the user's doing this on the page. So if you have event handlers, especially if you're bringing in third-party components that you can't control easily, then setting this will disable the browser defaults. And then you own responsibility for like setting the scroll position or doing whatever it is that you want to do. These are primarily there for games, for web games, where they really want the minimum latency on these events, but certainly I could imagine lots of applications that would consider it to be useful. It also disables double tap zoom.
This was on the playbook, but was it on BB7 as well?
Yes, so this has been since BlackBerry 6, actually.
Okay. So if you're building applications, you really want to take control here, and you're building a touch application, you want to do that. So in the futures, what are the things that are on our radar where we see a lot of activity? So there are big things, right? WebRTC is really big. This is, if you have, imagine building WebEx as a full web application, right? With video, with real time, all that type of stuff, right? That's kind of the dream of WebRTC. How do you build all those APIs to enable that to work? Web audio, as we mentioned, the audio tag, we got it a little bit better. We can play a couple of sounds, but there's no positional audio. The latency is still an issue, right? If you're building any type of gaming with a slight degree of complexity, the audio tag is just not sufficient. Web audio is what you want. So web audio is like WebGL. It really provides you access to the core audio infrastructure of the device. It's that level of complexity. It allows you to have like positional audio, link into element, have multi-channel logic, adding filters for processing and all that type of stuff. It's very rich. CSS continues to be an area of a lot of innovations, right? People keep on pushing CSS in terms of a really strong typesetting environment to replicate a lot of things around print. This has been pushed a lot by Adobe. So regions and exclusions are an example of that. You want text that flows around images. You want to have rich kind of layout capabilities to mimic, again, the type of creativity you can get on print and do that on the web. And then finally, we've talked about the CSS filters in the past, but there are ways actually to build much richer kind of shaders, like almost like WebGL shaders, and you can have custom shaders. So they were called like shaders in the past. They're now called custom filters. And that's another area of a lot of work within CSS. So more audio, video, multimedia, real time, and kind of layout, amazing stuff. That's kind of where this is cutting edge, right? So the whole industry is working on those. There'll be definitely progress over the next 12 months, but these are things that are going to take a little while.
No, web audio is a standard that is specified at a very high level, deliberately to not require a specific underlying API. And the web audio implementations that are out there are actually not built on OpenAL. So web audio is a pretty difficult thing to get right. So right now, I know that some of our competitors are pushing web audio as a new API, but the minimal support that's available actually makes it pretty difficult to use efficiently for the kind of applications where we think the audio tag isn't sufficient. So this is something that we're still working on getting right for web developers.
So the thing is, it's trying to not repeat the mistakes of WebGL in a sense, because WebGL was really tied to OpenGL and trying to make it more high level. But it is trying to achieve the same level of hardware control and trying to do it in a more abstract way, which is a lot more complex. So it's still something to watch and evolve over the next year.
Okay, so if you'd like to talk about this some more, we have a roundtable session in not very much time in the place where food is being served. Or please feel free to continue the conversation on Twitter, BBJam hashtag, and that's our session ID, Jam57. And don't forget to use the mobile conference app, which is a web app, and go to the 10,000 Reasons to Believe booth and record your video and get broadcast on the internet. So unfortunately, we're over time, and we don't have time for questions, but we will be around all day, and tomorrow at the unconference. Feel free to track us down and ask us your questions. Thank you.
Thank you.